Welcome to Mathmo. This video presents an introduction to trigonometry, which is a geometry topic that deals with triangles. So what is trigonometry, or trig for short? Well, here's what it does for us. When you have some information about a triangle, for example a side length and an angle, or maybe just two side lengths, then trig helps us to calculate other side lengths or the angles inside the triangle. Basically, it helps us to determine the shape and the size of the triangle. Now the triangle doesn't have to be right-angled, but right-angled triangles are a good starting point for beginners, and that's what we'll be focusing on here. So when you're at school, you normally hear about three trig functions called sine, cos and tan, and very quickly you're taught how to use them, but not necessarily what they mean or how they come about. You're taught how to spell SOH-CAH-TOA, and given some mechanical rules to follow, and if you follow the rules carefully enough, out pop the correct answers. But what are sine, cos and tan? I'm going to try and give you a bit more of a feel for what they are, and hopefully that'll make things easier when you actually come to use them. And don't worry, we will cover that in a separate video. Okay, so sine, cos and tan are three functions that operate on angles. You can give each function an angle, it performs a specific calculation depending on that angle, and it produces a number. So for example, you might use the sine button on your calculator to find out that sine of 40 degrees is 0.643. Or you might use the cos button on your calculator to find out that cos of 40 degrees is 0.766. But what do these numbers actually mean? Let's go through them one by one. The specific calculation that the sine function does is measure the vertical height of a right-angled triangle with a hypotenuse length of 1. Remember, the hypotenuse is the longest side of the triangle. It's the side that doesn't form a right angle, and it's labelled H in my diagram. So when the angle is very small, sine of the angle is very small. And as the angle grows, so does the height of the triangle. So when your calculator tells you that sine of 40 degrees is 0.643, it's telling you that this right-angled triangle here is 0.643 units high. That vertical side length is what we call the opposite side because it's opposite to the base angle. Another way in which we can remember that the side length is related to the sine function is that S stands for separate. We're looking at the side length that is separate from the base angle. Now let's move on to cos, which is short for cosine. So while the sine function measured the triangle's height, the cosine function measures the horizontal width of that same triangle. So when the angle is very small, cos of the angle is very close to the length of the hypotenuse. But as the angle grows, the narrower the triangle becomes, so cos is very small. When your calculator tells you that cos of 40 degrees is 0.766, it's telling you that this right-angled triangle is 0.766 units wide. That horizontal side length is what we call the adjacent side. Adjacent means next to, and this is the side that is next to or adjacent to the base angle. Another way we can remember that the side length is related to the cosine function is that C stands for connected. This is the side length that is connected to the base angle, and it's not the hypotenuse either. Okay, so that's sine and cos, but what about tan? Which sounds like it was made for me, but it's actually short for tangent. Well, tan can't be described as a length of this particular triangle, but what it does represent is the ratio of the opposite side to the adjacent side, and what I mean by that is tan is equal to sine divided by cos, or opposite over adjacent. So when the base angle is small, tan of the angle is also small, because the opposite side is a small proportion of the adjacent side. And when the base angle is large, the opposite side becomes many times bigger than the adjacent side, so tan of the angle can be very large indeed. And when the base angle is 45 degrees, the opposite and adjacent sides have exactly the same length. Notice how the triangle looks like half a square cut along its diagonal? And so the ratio is exactly 1. Now, of course, not all triangles have a hypotenuse of length 1, but don't worry, we can just scale the whole triangle up and down as necessary. So if we want the hypotenuse to be 3 times as big, then the other side lengths become 3 times as big as well. And now that we've introduced the notion of a ratio of 2 sides of the triangle to describe the tan function, I'll point out that sine and cosine can also be written as the ratio of 2 sides of the triangle. Hopefully you can see that we can divide by the hypotenuse to get back to the sine and cosine values. So sine is equal to opposite divided by hypotenuse, and cos is equal to adjacent divided by hypotenuse. In the case of sine of 40 degrees, we can say that the opposite side is roughly 64.3% of the length of the hypotenuse. Similarly, the value of cos of 40 degrees tells us that the adjacent side is roughly 76.6% of the length of the hypotenuse. Okay, so let's recap. Sine and cosine measure the height and width of a right-angled triangle with hypotenuse length 1. But more generally, sine is the proportion of the opposite side to the hypotenuse, and cosine is the proportion of the adjacent side to the hypotenuse. Meanwhile, tan is the proportion of the opposite side to the adjacent side. And now hopefully you can see where the mnemonic SOH-CAH-TOA comes from. It helps us to remember which 2 sides create the ratio associated with a particular trig function. Right, hopefully that brings a little more meaning to the trig functions and the values that your calculator produces. In a separate video, we'll work through some examples and show you how to actually use them. Thanks for watching.